Okay, we're going to solve some linear equations in this video. Let's start with a very simple equation. So it's x plus 1 is equal to 5. So it's called a linear equation because x is a linear function in this equation. So x does not have a power, it's not squared, it's not in the denominator, it's just a linear function of x. So x is only multiplied with some constant and there's some stuff added or subtracted to it. So how we solve this is by getting x by itself by doing the reverse operation with whatever is with x. So in this case here, we've got the 1. So we want to get rid of the 1. So we have x plus 1. And what we would need to do to get rid of the 1 is subtract 1. But in an equation, we can't just do that on one side. We have to do it on both sides so the equation stays true. So then what happens, this plus 1 and minus 1 cancels and leaves us just with x. And then this 5 minus 1 is 4. So there we have solved that x is equal to 4. Let us do another example. So here we have x plus 3 is equal to 5. So again, we would like to do the operation that removes this plus 3, which is subtract the 3. So we don't do that on one side, we do it on both sides. And then the 3's disappear on this, plus and minus 3 give us 0. So then there's just x. And on this side here, 5 minus 3 is 2. So often we leave out the step that we explicitly minus the 3 on the both sides and we say we take it over. So we have x minus 5 is equal to 6. So for this one over here, we take over the 5 and we change the sign. So that's the equivalent of these steps, the short way. So then this here is 6 and we change the sign plus 5. And then we get that x is equal to 11. We will do a few more examples. So we have x plus 4 is equal to 2. So we're going to subtract 4 on both sides. So we have x is equal to, it's the same as taking that 4 over and changing the sign. So minus 4. And then we get x is equal to minus 2. We'll do a few more examples just so that you are confident. So x minus 3 is equal to 8. So again, we will take this 3 over, and when we take the 3 over, we change the sign. So this is 8 plus 3, and then this x would be equal to 11. If we have something like x plus 10 is equal to 3, then we will take the 10 over and change the sign, so it becomes 3 minus 10. And it's always the thing that we are taking over that the sign changes. So this here is equal to minus 7. We have x minus 10 is equal to minus 5. So then when we take the 10 over, its sign will change. So the minus 5 sign stays the same, but the 10, when we take it over, its sign changes. And we have x is equal to minus 5 plus 10, which is 5. The next question is x plus 4 is equal to 12. So x is equal to 12, and we take over that 4 and change the sign. So x is 12 minus 4, which is 8. We have x minus 5 is equal to minus 2. Again, that minus 2 stays there, and when we take over the 5, its sign changes. So here we have x is equal to minus 2 plus 5, which is 3. The last example is x plus 6 is equal to 4, and we'll have x is equal to 4, and we take the 6 over, and the sign changes, so we have x is equal to minus 2. So that is the first and simplest case of solving a linear equation. So x's coefficient is 1, so there's just been x with a coefficient of 1, and we've just seen how to get x by itself if we've added or subtracted a term to it. So we do the reverse operation or the inverse operation. So we would subtract 3 if it was a plus 3, and we do it on both sides, and that's how we would get x by itself. So in this case here, we subtracted it on both sides and we got x is equal to 2. And in this case here, when it's added, then we subtract it on each side. And we've also gone over that when this is a shorter way of minusing or adding it on each time is by taking it over and changing the sign, which is essentially this what we are doing. So this 3, if you take it over and change the sign to -3, that is the same as adding what we've been doing to add the inverse operation. So please go over these examples in this video again and see that you can do all of these. If you can, please do move on to part 2.